Welcome back to Low Stress Math with Mrs. Bono. This is Lesson 5, Dilations, Unit 7, Transformations, and I just realized I never ever put the words Lesson 5 up here. So this is Lesson 5, Dilations. And dilations is a transformation that produces an image that is the same shape as the original, but a different size. So I'm going to write same shape as the original, but a different size. So a dilation is similar to the original figure. And I just realized that's kind of small. It's similar to the original figure. Dilations are centered about the origin, unless otherwise stated. In other words, the otherwise stated part is just not going to happen because you're in 8th grade and this is pre-algebra, so don't worry about that. But just know in the future, they might make the center of dilation something else, which changes everything, and yeah, let's ignore that for a while. Scale factor is the change, and the way you find scale factor is you take the image length and you divide it by the pre-image length, which is a ratio. So let's think about the real world and a map. So in the real world, from my house to Bayshore Middle School is about 2 miles. But on a map, it might only be 2 centimeters. So the ratio is 1 mile to 1 centimeter, because you would divide it and then put the units in. So if the scale factor is greater than 1, the scale factor is greater than 1, then the image becomes larger. But if the scale factor is between 0 and 1, in other words, let's just write that under here, a fraction, then the figure becomes smaller. So let's take a look at this. XY becomes FX, FY, where F represents the scale factor. I mean, that kind of makes sense because, factor, silly little f there. So if the scale factor is 3, how would you write this rule? Haha. So what they're saying here is that f equals 3. So x, y would become 3 times whatever x is and 3 times whatever y is. Dilations are my favorite because they're pretty much the easiest one. So here's my triangle. I have A at 0, 2, B at 4, 4, and C at negative 1, 4. What are the vertices of its image with a scale factor of 4? In other words, they're saying that the F here is equal to 4. So if I have X and Y, it's going to become 4 times X and 4 times Y. So I just have to take all of my given numbers, my originals, so I have here A at 0, 2, and B at 4, 4, and C at negative 1, 4, and I'm going to write the scale factor in red, just so you see that it doesn't change when I'm multiplying it. So it's going to be 4 times everything. So 4 times 0, 4 times 4, 4 times negative 1. Those will be my x values. 4 times 2, 4 times 4, 4 times 4, those are my y values. Well, lots of parentheses going on there, crazy old Bono. So my new one A prime, well, 4 times 0 is 0. 4 times 2 is 8. So my new A prime is at 0, 8. B prime, 4 times 4 is 16. 4 times 4 is 16. So my new B prime is going to be at 16, 16. And C prime, 4 times -1 is -4. And 4 times 4 is 16. So my new C prime is going to be at -4, positive 16. And so you just take the scale factor, here was 4, and multiply it times every single coordinate. Like I said, dilation, my favorite. So let's look at this quadrilateral. It has -2, 4, 4, 4, 4, -2. Oh, such silly numbers. And it's dilated by a scale factor of 1/2. So I'm going to write that 1/2 in red. So here, I'm going to write all of my coordinates over here so you can see what I'm doing before I graph it. Okay, so P is at -2, positive 4. Q, 4, 4. R, for -2. And S, -4, -4. Now, all of those are being multiplied by 1/2. But multiplying by the 1/2 is the same as what? Dividing by 2. So all I really have to do is take all of these numbers and divide them by 2. So -2 divided by 2. 4 divided by 2. 4 divided by 2. Oh, there's so many 4s. -2 divided by 2. -4 divided by 2. And -4 divided by 2. So take everything and just divide it by 2. That's the same as multiplying by 1/2. I know you remember it, but you don't really remember it. It was way, way long ago, back in the beginning of the year when we reviewed that. So, look at this. We're reviewing the beginning of the year whilst doing new stuff. So, P prime, -2 divided by 2 is -1. 4 divided by 2 is 2. So my new P prime is going to be at -1, 2. Q prime is going to be 2, 2. And R prime is going to be 2, -1. And S prime is going to be at -2, -2. So now I just have to graph everybody, right? Okay. So I'm going to graph the original image, -2, positive 4, 4, 4, 4, -2, and -4, -4. What an ugly shape. Okay, don't be judgmental of the shape of the thing that you're graphing. Just find your ruler and graph correctly. Here we go, ruler. Connect the dots. And here's my shape. And as I look at it, I realize it kind of looks like a kite, but nothing is really parallel. I'm not really sure I like this shape. But there it is. So now I just have to graph the new one. Now, remember, it's going to have the same shape, but it's going to be smaller because we multiplied by a fraction. So P prime at -1, positive 2. Q at 2, 2. Q prime, sorry. R prime at 2, -1. And S prime at -2, -2. Now, see, it has that same kind of kite shape. So you know you graphed it right if it has the same shape, but it's either larger or smaller. In this case, I'm multiplying by a fraction, so it got smaller. On the last page, we multiplied by a whole number greater than 1, so it got larger. Now, here's the part that people forget. When things are similar, their sides are in proportion. Let's write that down because the next problem says demonstrate that these are similar by comparing the ratios of the lengths. So I can't do all of them, but I can do 2 of them. So similar shapes have sides in proportion. So what I'm going to do is I'm going to compare the sides. And I'm going to take the sides that are easy to compare because just a little bit lazy on my part. I'm going to compare PQ to P prime Q prime. So PQ to P prime Q prime. And QR to Q prime R prime. So in order to make them a proportion, you have to have side to side. Here we go. So PQ, P to Q is 1, 2, 3, 4, 5, 6 boxes. 6 boxes. And Q to R is 1, 2, 3, 4, 5, 6 boxes. 6 to 6. Now I want that to be equal to P prime Q prime, which is 1, 2, 3 boxes over 1, 2, 3 boxes. All right, let's see. How do you know sides are in proportion? Well, they reduce down to the same thing. 6 divided by 6 is 1. 3 divided by 3 is also 1. So those are in proportion. It did work. Now you could set up the proportion a lot of different ways. And as long as it reduces down to the same number on both sides of the equal sign, then it's in proportion. What do you notice about the angle measures of the 2 figures? Well, because the figures are similar, the angle measures are equal. The easiest one to see on this graph is angle Q and angle Q prime. They're both 90 degrees, so they're equal angles. The other ones are also the same. That's how they get the same shape. Same angles, same shape. Sides in proportion. All right, let's take a look on the next page. Dun, 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 dun. Am I on the right page? No, Bono, you are on the wrong page. Here we go. If the scale factor is 5/2, how would you write the general rule? So I'm going to write 5/2 in red and the X and Y's in black. So the scale factor times the X and times the Y. So how would I write that general rule? I'm going to do 5/2 times X and 5/2 times Y, because you multiply the scale factor times everything. Now, how do I know if it's an enlargement or a reduction? Well, let's take that 5/2 and make it into a mixed number. 2 goes into 5 twice with 1/2 left over. 2 1/2 is greater than 1. So because it's greater than 1, it's an enlargement. Doesn't matter that it's a fraction. It's a fraction greater than 1, so that's what makes it bigger. All right, here's a dilation. Find the scale factor. Oh my goodness gracious me. How could I possibly find the scale factor? Well, what I'm going to do is I'm going to look at these 2 points, the B and the B prime. Now remember, it's always the image over the pre-image. And how do you know which one's the image and which one's the pre-image? The image has these little slashy marks next to it, and the pre-image does not. So here's my image. It's 6. Oh, sorry, I lied. It's 2/6. So the image is at 2, and the pre-image is at 6, because that one has a little thing. Now, how come I didn't put the zeros? Because, you know, it's 2, 0, and 6, 0. Because when you multiply anything times 0, it's just gonna turn to 0. So I don't need those numbers. I just need the, y values. So 2/6 reduces down to 1/3. That's my scale factor. Let's check it. Let's do it on A and A prime. Here's A, which is at 6, 0. There's my A. Now, if I multiply A to get A prime times 1/3, well, let's see, 1/3 of 6 is 2, 1/3 of 0 is 0. I should have A prime at 2, 0. And look at that, there's A prime at 2, 0. And I could check all my points that way. But I'm not going to because I'm lazy. So my scale factor is 1/3. There we go. Puffy cloud of happiness. Last one. Triangle XYZ is graphed below. Triangle X prime, Y prime, Z prime after a dilation using a scale factor of 2. So I'm going to write down my original coordinates. X, which is at -1, -1. Y, which is at -1, 2. And Z, which is at 1, 1. My Z looks like a 2, so I'll put a line through the middle of it. Now, I just have to multiply everything times 2. I'm not even going to write that out. So X prime, 2 times -1, -2. 2 times -1, -2. Y prime, -1 times 2, -2. 2 times 2, 4. And Z prime, 2 times 1 is 2. 1 times 2 is 2, and it's at 2, 2. So now I just have to graph that. So -2, +2. No, -2, -2. Do it right, Bono. So there we have X prime, -2, +4, Y prime, and +2, +2, Z prime. Connect the dots. Dot, 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 dot. Hold it steady, Bono. Don't make those old wobbly bad dot lines. And there we go. What will be the coordinates of Y double prime after a reflection over the x-axis? Well, there you go. Now I have to go back and I'm going to reflect over X. But it didn't ask me about all of the points. It only asked me about Y. So it's only Y that I'm going to reflect. Y is 1, 2, 3, 4 to the line, so it has to go 1, 2, 3, 4 on the opposite side. So Y double prime is there. Now remember, my Y double prime is after I reflect Y prime. Be careful. Make sure you reflect what they tell you to. So I have -2, -4. And if I'm a little lazy and don't do extra work, well, that's just me. I'll talk to you soon. Take care. Bye.